When ice melts at the poles, of course that makes a difference in the conditions at the poles. What was once a cold, white, solid surface becomes a dark expanse of water. But that's only one side of the story where the ice was lost. What happens to all that water? Of course, the ocean is already full of water, so what difference does adding water to the ocean make? It turns out that extra water makes a lot of difference in places far away from where that ice is melted. The water running into the sea from melting polar ice is literally adding enough water to the ocean to make the water level rise across the entire ocean, which affects any place where land meets the sea. This means sea level rise is a concern in all coastal areas and islands all across the world. For this illustration, I chose just the Bahamas as an example to show you because it's a small island country far away from the icy poles. Well, this map shows the near-term projected sea level rise, and the areas in red show areas that will be flooded annually, every year by 2023, and 2023 is pretty much now. Sea level rise is partly caused by the melting of ice at the poles, but there are other causes. Ice is also melting off of inland glaciers in places like the Himalayas and the Rocky Mountains, much faster than they have in the past, moving a lot of water into the sea via rivers. And as we pump groundwater out of aquifers for irrigation and drinking water, it ends up running into the sea. That's a lot of water removed from where it has been stored for thousands of years and moving it into the ocean. But sea level rise is not only due to an increase in the amount of water received by the ocean from land and ice. The added water entering the ocean is also warming. And of course, water expands as it warms. You know that if you've ever left your water bottle on the dashboard of your car and had it swell or rupture. So the water in the ocean is actually growing in size, which is causing the surface to move upward and encroach on the land. The combined effect of these things is that global sea level has already risen between 8 and 9 inches since 1880. What's much more striking is that the speed of the change is increasing fast, with the most annual change happening in recent years. The change between 2006 and 2015 was more than double the annual change for most of the 20th century. Just like a 2-degree change in global average temperature, a 9-inch rise in global sea level doesn't sound like much, but it's enough to cause a big difference in a lot of places. Even if the ocean were always calm and still, many coastal areas are pretty flat, so a little rise in the height of the water means a lot more of the land at the water's edge ends up underwater. That's why many island nations and coastal communities are concerned about their loss of landmass. I've put a collection of YouTube videos about places that are disappearing due to sea level rise in the connector for you. I think you'll find them pretty interesting. I also encourage you to go take a look at NOAA's Sea Level Rise Viewer, which I've linked for you in the connector. This tool will let you zoom in on any coastal area and then explore how the coastline changes with different amounts of sea level rise. I was really interested to see how much rise it would take to flood my daughter's house. But I know that question is a bit simplistic since it doesn't capture the risk to her house from even a moderate change in sea level. I started this discussion about areas being flooded by sea level rise with the assumption that the water is calm and still. But of course, this is not the case. Water is always moving, both in regular ways with the ups and downs of the daily tides, and in more extreme ways with storms and wild weather. We've talked about storm surges, and of course it is obvious that the area vulnerable to this hazard grows with even small changes in sea level. There's one last thing I'd like to mention about sea level rise before we move on, and that is the effect on coastal ecosystems. The moving coastline and added water depth can swallow up habitats like coastal marshes and beaches, as well as pushing coral reefs and seagrass meadows deeper and out of the sunlit surface waters they need. Since these coastal habitats are critical for so many marine species, this is a big concern for biodiversity. Globally, rising seas have already begun to cause some serious havoc with these habitats.